This is an SPD, and today that bread that they have been using to soak inside your soup and take it out and eat it like that, we are going to burglarize that their bakery today. I'll be explaining to you what an SPD does and if you actually need it or not. An SPD simply consists of three devices: metal oxide varistor. Now, metal oxide is the main component used in these devices, and the varistor simply means the variable resistor. You know, when you turn your standing fan and then you can increase the fan speed to one, from 1 to 2 and 3 and stuff like that. Yeah, a variable resistor is simply something like that, but then it's automated. So at a threshold, it would actually cut off on its own without you touching it. You don't need to do anything. It's automated. While the one in your fan is actually called a potentiometer, also a variable resistor also, but it's called a potentiometer. You can increase the fan speed and stuff like that. Now, this is a DC surge, which is why it is red. In some cases it is white. The China knockoff versions, they are white, but they actually work the same way. The principle is the same. And this is an AC surge. The AC is green and white, while the DC is red. The concept inside these two is actually the same, and the only difference is that this DC surge activates at 1000 VDC, which means until it sees a voltage that is above 1000 VDC, this actually will not trigger. And the same thing with this one. This is rated for 350 VAC, and until it sees a voltage spike that exceeds 350 VAC, it will not activate. I'm trying to remove one of the cartridge to show you. Yeah, so this is the cartridge for the AC surge. Same thing goes with the DC surge also. So you can also remove this, and they are replaceable. At some point they get burnt, so you can see it from this window, this little window. They turn red once they get burnt. Now, what happens is that when there's a sudden increase in voltage, now you have this curve, this first curve, it goes from here to here. Now, this is the normal AC current. Now, over here, if you check this curve, you can actually see a sudden spike here, and then it goes all the way and then it continues again. This sudden spike might occur for just microseconds or milliseconds, in some cases milliseconds, just 1 millisecond, just like thunder strike. And there are different sources of voltage spike. There are different reasons for surge. The first one is if you are using heavy equipment, if they are using heavy equipment around your house, or you yourself are using heavy equipment that constantly drags a lot of current from the grid and then returns it back to the grid. That's source number one. So that one is more like man-made. They are from equipment, like you have heavy factories around you, but like if you have companies that works with heavy metals and cuts them, all this, their equipment, heavy equipment and stuff like that. Or you have companies like Yale around you that uses heavy equipment to make biscuits and stuff like that. That is source number one. Then source number two is thunder strike. So it sends you high voltage, low current, and sends it into your system. So what happens when that hits this kind of devices is that, number one, when these devices are when you are using these devices under their stated voltage limit, now they have high resistance and no current at all. So they are just sitting down idle. There's high resistance between this pole and this pole and this pole and this pole. So basically what I'm trying to say is that you can say I said this pole and this pole and this pole and this pole, because this pole, you can actually see here, there's actually two connectors between here, and these two lower poles are actually connected, while this one is isolated. Now, the way this device is able to monitor these two poles is actually because of these two cartridges. You can see I removed one and there was still one again. So probably I should remove it again so that you can understand what I'm saying. So now I've removed it again. You can actually see a contact from here and another contact from here. You can see two contacts there. Yeah. So this device is actually the one doing the job. So when there's a surge above here, it actually activates this varistor here, and then it contacts this and this together. the two poles, it contacts them together. So when there's a surge from here, it connects it to this side, and then it drains it out through the. Now let's take a look at this device. On top we have two connections, but at the base we have just one connection. So here we have two connections coming in, which is a line and neutral, excuse me. And then at the base we have your ground. So this is going to your ground connection. But technically we have these same two connections here, but they've been linked, so we only need one source to connect it to your earth connection. So what happens is that when there's a spike on the line connection, so let's connect your line here, and then there's a spike in the voltage at the idle state of this SPD. What happens is we have a high resistance and low current, or no current at all. We have no current and we have high resistance. But when that voltage spike comes in and this activates, we have low resistance and high current in this, which means it will generate enough heat to actually activate the variable resistor and link the pole from here, the line, to the ground. So it links this all the way to this point, and then the energy, the excess energy, drains out of this system. So which means instead of the energy going to your own devices, it gets drained to the earth connection of your house, and that way you don't even know anything happened. And the same way, if it happens from the neutral connection also, this one actually senses that, and then this one will get burnt and then send the excess energy to your ground, and that solves the whole problem. Now once in a while you need to go back and check these devices to see if any of these windows is indicating red, and the red means it is actually burnt, and you can't it will not activate the next time there's a surge or there's a voltage spike, anything like that, it will not activate. So that is why they made this a replaceable fuse, a replaceable cartridge rather, said fuse. So let's assume this is burnt, and this is exactly how I'm going to replace it, and then you can buy a brand new one and then just slide it in just like that, and you're protected again. Now whenever this device is installed in your system, you don't have to worry about thunder strike or whatever. In some cases where this and this are both installed and then thunder still affects your system, then the next question is this: when last did you service your thunder arrestor? Number two, do you have a proper grounding system in your house or on your electronics? So most of you will ask me, but we have ground, the DB has ground. How many of that your wall socket has ground wire, ground cable? Or you think that wall socket that they will bring, that they will put ground, you think it's just there for decoration, abi? I only have few customers who have proper grounding system in their house. There's a difference between grounding your wall sockets, your wall outlets, your switches and stuff like that, and you just having an arrestor on your roof that goes into the ground. If the two of them are not properly synchronized together, if the two of them are not properly connected, it will still not work. You just have 50% protection. If by luck the arrestor takes the whole voltage spike and sends it down to the system, that's one way of it entering your house. But if it enters through the AC system, your probably your electricity pole, and then comes straight into your system, and this guy is there, but then it is not connected to that live and neutral that goes to your appliances, or it is connected to them, but then this ground is not connected. This one is just connected to the DB, but then the DB is not connected to your television's wall outlets, or the ground from this one is not connected to your wall outlets and stuff like that. Then it's still not going to work because you've done half job. So this is where you need to know if this one is actually going to work for you or not. So first thing first, call your electrician, talk to him, man to man, or woman to man, or man to woman. In any case, talk to them. Do I have a proper grounding system in my house? So if you have that, then you call your solar technician or your electrician. If he does knows what he's doing, ask him, I need to install this system in my house so that it will protect me from surge and stuff like that. And then if they know how to do it, then you're in good hands. But if they don't know how to do it, you can kindly reach out to me, and then I will help you install it. Of course, for a fee. Thank you, and you're welcome too.